Something we can do as we consider planets is to try and figure out what temperature the planet should have. Specifically, how much energy does it receive from its star, and then how much of that energy is it able to radiate away. We get a balance between how much it's getting from the star and how much it's able to give off, and that gives us what's referred to as the equilibrium temperature, the temperature it should have if it's only being heated from the star and giving off that heat back into space. This temperature is known as the equilibrium temperature, the equilibrium between what it's getting and what it's giving off. Now, something that affects the equilibrium temperature is the planet's albedo. The albedo is how reflective a planet is. A planet with a higher albedo is more reflective, meaning it's going to reflect more of that light back into space, and if it's reflecting that light, it doesn't absorb it and actually heating up. So we expect a planet with a higher albedo that is more reflective to actually be cooler than a planet with a low albedo that is darker, where it absorbs more of that energy. Well, as we take all of these things into account for the Earth, the equilibrium temperature should be around -19 Celsius, which is -2 Fahrenheit. In other words, the Earth should be so cold there should not be any liquid water anywhere. And yet we know that is not true. The actual surface temperature is around 14 degrees Celsius or 57 degrees Fahrenheit. Now, this is global average. Now, this difference between what it should be and what it is actually is caused by the greenhouse effect, which I'm fairly certain you've probably heard of already. But just in case, the idea of the greenhouse effect, there are certain elements, certain molecules within our atmosphere that are transparent to visible and ultraviolet light, but interact very strongly with infrared light. So some of these molecules are water vapor, carbon dioxide, and methane. All of these are transparent to visible and ultraviolet, but are opaque and interact very strongly with infrared light. So what happens is we get ultraviolet and visible light coming in from the sun. This hits the ground. Some of it is immediately reflected back out into space, which doesn't actually heat up the planet at all. However, some of it does get absorbed, which heats up the surface. As the surface heats, it then begins to emit its own infrared heat, but this infrared light is scattered and becomes trapped close to the surface of the Earth. So it's kind of like wearing a blanket, where you trap in all that heat close to the ground. The reason why we refer to this as the greenhouse effect is because this is what greenhouses do. Now, instead of using molecules like methane and water vapor, they use glass, but it's the same principle. Glass is transparent to ultraviolet and visible light, but it will trap in the infrared light, heating up the interior of the greenhouse much more than it would be normally. All right, here is our fifth lecture quiz question. The greenhouse effect is A, good thing because it means the Earth is warm enough to maintain liquid water, B, a bad thing because it could heat a planet enough to render it unsuitable for life, or C, it can be both good and bad. Go ahead and think about it, and we'll discuss in just a bit. So, is the greenhouse effect good or bad? The answer is C, both. If it wasn't for the greenhouse effect, the Earth would be frozen over, there would not be life on Earth. However, we're going to see just how bad the greenhouse effect can get when we talk later about Venus. Now, just as the Earth's interior has different layers, so does the atmosphere. The atmosphere is the layer of gas surrounding a planet. The lowest layer of the Earth's atmosphere is the troposphere. It is within the troposphere that all weather, or everything that we associate with weather, occurs. Now notice the temperature trend through the troposphere. So on this graph, up and down, we're looking at altitude. So 0 is ground level, and then going up higher and higher and higher. Then along the bottom, we're looking at temperature. So as we go higher and higher in the troposphere, it cools off more and more. This then, because it's warm on bottom and cool on top, leads to convection, and it's that convection that then generates the winds that we experience, as well as allows for cloud formation and other things. So again, everything we associate with weather is occurring within the troposphere. The next layer is the stratosphere. Within the stratosphere, we see the opposite temperature trend, where the higher you go, the warmer it becomes. This is because of ozone. The ozone layer of the Earth is within the stratosphere, and you've probably heard of the ozone layer. This is a layer of a molecule called ozone within our atmosphere that actually protects us from harmful ultraviolet light. Now, as this happens, the ozone interacts with ultraviolet light, but that then allows it to release the light as infrared. So this generally heats up the stratosphere. The higher you go, the warmer it becomes. The next layer is the mesosphere. The mesosphere has the same temperature trend as the stratosphere, where the higher you go, the cooler it becomes. Then the last layer of the Earth's atmosphere is the thermosphere. Now again, in the thermosphere, the higher you go, the warmer it becomes, similar to the stratosphere. However, in the case of the thermosphere, it is not ozone that is causing it. It's actually individual oxygen and nitrogen atoms. The oxygen and nitrogen atoms absorb ultraviolet and then re-release it as infrared, heating up this region. Now, temperatures within the thermosphere can be greater than 1,000 Celsius, which is really, really high. However, it's not actually dangerous because the thermosphere is so thin. The higher you go, the thinner the air becomes. So the air at this area of the thermosphere is so thin that it actually has very little energy. So if you remember back, we talked about the difference between thermal energy and temperature. Although this has a very high temperature, it has a very low thermal energy, so it's not actually dangerous in any way.